Have you ever looked at a wasteland and seen the future? Look closely at this sprawling expanse. Millions upon millions of discarded, rusting, and weather-beaten oil drums stretching as far as the eye can see. To the average person, this left to rot, they would take centuries to decompose, slowly leaking toxic residues into the earth and poisoning the groundwater. But human ingenuity has a remarkable way of turning a crisis into an opportunity. This is not the end of the line for these drums.
It is merely the waiting room for one of the most spectacular transformations on planet Earth. Today, we are taking you inside a billion-dollar mega facility.
A mechanical beast that eats toxic waste and breathes the very spine of modern civilization. Our journey begins at the intake yard, an area of the factory that operates 24 hours a day, 7 days a week. Massive front-end loaders scoop up dozens of barrels at a time, dropping them onto a primary conveyor system. But there is a massive problem. These drums cannot simply be thrown into a fire. Many of them still harbor dark secrets. To prevent a catastrophic explosion, precision robotic arms equipped with sharp pneumatic spikes violently puncture the bottom of each barrel. The toxic black sludge oozes out and is carefully funneled into underground containment vats, ensuring environmental safety. This intense pressure washing strips away decades of dirt, flaking paint, and stubborn rust. They emerge from the
The clean steel is currently too bulky and full of air to be melted efficiently. To maximize the capacity,
the drums are fed into a colossal hydraulic press. With a terrifying force of over 2,000 tons, the equivalent weight of
The crushed blocks are carried up a steep incline and dropped directly into the belly of the beast, the industrial mega shredder. Stories. It violently pulls the pure iron and steel upward, leaving behind any non-magnetic impurities like...
Now, we enter the most extreme environment in the entire factory. The shredded scrap is dumped into a gigantic...
Traditional furnaces burn coal or gas, but to achieve the absolute purity and extreme temperatures required for high speed.
Then, the operator hits the switch. A massive surge of electrical current, enough to power a small city of 50.
The electricity jumps between the electrodes and the metal, creating artificial lightning. The resulting electrical arc generates...
But recycled steel is inherently unpredictable. To ensure the final railway tracks possess the legendary strength
Based on precise computer calculations, they inject specific alloys into the melt. Carbon is added for
The molten alloy is ready for rebirth. The massive furnace tilts, pouring the liquid.
This vessel carefully regulates the flow of the molten steel into a continuous casting machine. As the liquid metal flows downward through water-cooled copper molds, a miraculous transition occurs.
What emerges from the bottom of the machine is breathtaking to witness. A continuous, endless. These thick, rectangular logs are known in the industry as blooms. Because they are
To cool them just enough to hold their shape during the next phase, banks of high-pressure water jets spray the moving steel.
But a thick, rectangular block cannot carry a train. To transform into a railway track,
This is a masterclass in mechanical engineering and applied physics. The red-hot steel is fed into a series of increasingly tight, specially shaped rollers.
With every single pass through these massive steel cylinders, millions of pounds of pressure squeeze the metal.
Because it is still glowing hot, the steel doesn't break. Instead, it yields. It is forced to stretch out.
The rollers are precision machined with grooves that gradually sculpt the metal. Pass after pass, the blunt rectangular block.
And finally, into the iconic, flawless, asymmetrical eye profile of a modern railway track.
Through the sheer, brute force of the rolling mill, a single compact block of steel has been stretched into a continuous... The forging process is violently hot, but the cooling process requires absolute patience.
Here, they are laid side by side, perfectly straight. Cooling is a critical metallurgical step.
If it cools too slowly, it will remain soft and warp under the weight of a train.
Once the structural integrity is locked in, the steel enters the finishing stage. Giant industrial circular saws,
Precision automated drills then pierce the web of the rail, creating the flawless bolt holes required to join the sections together.
In the world of high-speed rail, there is absolutely zero tolerance for error.
A train carrying 1,000 passengers traveling at 350 kilometers per hour relies entirely on the perfection of these two strips of steel. Therefore, the final stage is purely analytical. Every single millimeter of every track is subjected to a gauntlet of automated inspections.
Only the tracks that pass this rigorous testing are stamped with a seal of approval.
Finally, massive automated robotic cranes lift the heavy rails, stacking them neatly into bundles, ready to leave the factory.
Heavy-duty gantry cranes load the steel bundles onto specialized flatbed trucks and cargo trains.
A massive convoy departs the mega facility, carrying the heavy load across highways, heading towards
At the construction sites, sophisticated track-laying machines will seamlessly guide these heavy rails onto concrete sleepers.
Take a moment to reflect on what we have just witnessed. What started as a hazardous mountain of rusting
Through the incredible power of heavy industry, the purifying force of fire, and human engineering.
Hit that like button, subscribe, and let us know what massive industrial transformation we explore next.